working on it a little bit before we did our story. This one was a little tricky on where to start. Does anyone have any ideas on where to start? Because we've got a lot of shapes, which means we have a lot of unknown numbers. They're all spot savers for numbers, but we don't have a lot of numbers to work with. Michael, where would I want to start?
I started on the second one with the two reindeer and the snowflake because I tried numbers and I tried like adding them up, so I knew 4 plus 4 would be 8 and then up to 4 would be 12.
So, but reindeer and snowflake are different shapes.
But they're equal.
So, Blaine, I hear you say that they're equal. If we look at that third equation, if we look at that third equation, we see that reindeer and snowflake are equal. That tells me they're going to be the same number. So if I then start looking at the second equation, this is the same number plus the same number plus the same number is equal to 12. What is something plus something plus something that's equal to 12? It's got to be all the same number. Clay, didn't you figure it out? 4. So if this reindeer is worth 4, this reindeer is worth 4, this reindeer is worth 4, this reindeer is worth 4. And we also know the snowflakes. I think we've got a good equation now that we can start with. Doesn't have many unknowns. Where would I try and work now? Devin? Okay, read it to me. 4 minus 3 equals snowman. What is snowman going to be worth? Probably 1. That means this snowman is 1. So now we got to figure out Christmas tree. We got 2 Christmas trees plus the 1 is equal to 17. This is a really good one to try and put some numbers in. I like to start with easy numbers like 10. If I pretend Christmas tree is 10, I have 10 plus 1 plus 10. 10 plus 10 is 20, plus 1 is 21. Is that equal to 17?
No.
No, it was too big. That means that my Christmas tree has to be smaller than 10. My other easy number that I like to try because it's easy to add with, 5s. 5 plus 5 is 10 plus 1, 11, not 17. This time it's too small. So now I know it has to be bigger than 5, but smaller than 10. Has anyone ever figured it out yet? Have you figured it out what Christmas tree is going to have to be, Tinley? 8. What is 8 plus 8, Tinley? 16 plus 1 is 17. So Christmas tree is equal to, what do we say, 8? 7, 8. Christmas tree is equal to 8. Oh, tricky. Tricky. Yes. All right, so go ahead on the next blank page. Here's your title. We're going to be talking about that equal sign. What is the equal sign telling me? We're going to be translating that equal sign from math language into some actual English. What the equal sign means. When I read an equation with an equal sign, what is that equal sign telling me? You've seen equations with equal signs lots of times. What does that mean? What does that equal sign mean? Michael, what does it mean?
It means what the two numbers, not the two numbers, what really any number added or subtracted is going to be the total.
Not quite. We're going going to break that because I know what a lot of you think. It's not just the total. Because when I subtract, I'm not finding the total. Remember, I'm finding the difference. That's a little bit different. So what is that equal sign telling me? Harper, what is it telling me?
It's telling you what two numbers put together or subtracted mean. Or what it
Not going to tell me what they mean. Ashley, what is the equal sign telling me?
what two numbers combined in it.
If we are adding, yes. But we're not always adding, are we?
No,
Tricky. What does that equal sign tell me?
like the value of a number.
It's got something to do with the value. That equal sign tells me the values of both sides of, and I'm going to write the equal sign because we know there's usually something on the left side and something on the right side. Both sides of that equal sign are worth the same. They have the same value. The values of both sides of the equal sign are worth the same. They are worth the same. We're used to the equal sign being the answer comes next. But that is not what the equal sign means. The equal sign is telling me, hey, this side is worth the same amount as this side. We're used to seeing
We know that's equal.
the answer sign, or sorry, the answer comes next. That's what we're used to seeing. But we saw something crazy like this yesterday. Whoa. Those aren't answers. Those are two little expressions now. Do they look the same?
No.
No, they don't look the same, but they are worth the same. That equal sign is saying, hey, the left side of me and the right side of me, they have the same value, even if they look different. We're definitely used to the equal sign. We use it a whole bunch. But what do we use if an equation is unequal? That prefix un, we've talked about that before. It doesn't mean opposite, it means not. It means not. You can think of it like an opposite, but it means not. You've actually seen equations that were not equal before. You have. If I write 3 plus 9, 10. There's a special symbol that I will need to put in there to show that they are not equal. It's not an equal sign.
It's like that little arrow.
What symbol could I put in there to make that equation true? I know that 3 plus 9 does not equal 10. 3 plus 9 is equal to 12. So what am I going to put in there? What symbol to show that? When?
Thank you, ma'am.
Thank you. I can. So this symbol right here, it is an equal sign with a slash through it. That will work. That is the does not equal symbol. That symbol right there means does not equal. Pretty simple. That will totally work. There's another symbol that we can use that is a little bit more descriptive. It tells us a little bit more information. it'll probably tell us which side is greater or less than the other side. Does anyone know what symbol I might be talking about? Shelby? Yeah, sometimes we call it fun names, but we have the greater than symbol. For those of you who remember that alligator mouth, the wide part of it is going to be pointing towards the larger value. So 3 plus 9 being worth 12 is larger than 10. I have the greater than symbol. It's another way to show that an equation is not equal by saying that one is greater, worth more. 3 plus 9 is worth more than 10. That's a little tricky because 3 is a smaller number than 10 and 9 is a smaller number than 10. So together it is worth more than 10. So if I rework my equation and I start with my 10, I can write the equation this way, which now I would say 10 is less than 3 plus 9. So when I put my alligator looking mouth the other direction, when I read it, just like I read a sentence, now this says that it is less than. 10 is less than 3 plus 9. So we now have 3 additional symbols to use when we are writing in math language to show if an equation is unequal or not equal. We're going to look at some equations and determine if they are true, if they are equal, or if they are unequal and we need a different symbol. Okay? All right, go ahead and write this one. Oh, we just did that one. Sorry. Go ahead and write this one on your paper. It says 10 is equal to 2 groups of 5. You don't need to write true or false. 10 is equal to 2 groups of 5. Remember, when we use our equal sign, we're looking at both sides of my equation. What's the value of 10? 10. The value of 10 is 10. What's the value of 2 groups of 5? Elena? No. Groups of 5 is not 5. Want to try again, Elena? 10. Is this equation true? Yes, it's got the right symbol. Let's put a T next to it for true. All right, next one. 12 is equal to 13 minus 2. Go ahead and write that. 12 is equal to 13 minus 2. Again, we are looking at the value of either side. What is the value of 12, everybody? 12. Raise your hand. What's the value of 13 minus 2? Ashley? 11. Is this equation true right now?
No.
No, this is false. Can you make it true?
Yeah.
How could I change out that symbol? I'm not going to use an equal sign. I'm going to use a different symbol. What symbol could I use? Devin? Yep, I could write 12 is unequal to 13 minus 2. What's a better symbol I could put in there? That one is correct, but there's a better symbol I could put in there. Harper? 12 is greater than 13 minus 2. 12 is greater than 13 minus 2.
facing the other way.
Yeah, so I could write 13 minus 2 is less. That'll work, yes. Not right now. Ooh. 20 divided by 5 equals 2 times 2. 20 divided by 5 equals 2 times 2. All right, let's look at probably the easier side first. What's the value of 2 times 2? What does that equal to? Layden? 4. Division. A couple of ways we could do this. We could make our 5 groups and deal out. We know that division is very similar to multiplication. Can I skip count by 5s and count my groups until I get to 20?
Yeah.
Let's do it. Ready? 5, 10, 15, 20. How many groups was that? 4. 20. Put into 5 groups gives me 4 in each group. Is this equation true? Is it true?
Yes.
Yeah, it does have the right symbol. True. Try this one, write it down. 3 minus 3 is equal to 5 plus 1. Go ahead and determine is it true or not. If it's not true, rewrite it with the correct symbol. Raise your hand to tell me, is this equation true or false? Please stop your hand. Is the equation true or false? Jackson, true or false?
False.
False. So that means I need to rewrite it. How could I rewrite this equation?
3 minus 3 plus 1. 5 plus 1 is 3.
Okay, so if I'm reading it like a sentence, I'm going to say 3 minus 3 is less than 5 plus 1. I could put the not equal sign in there, unequal sign in there, that would work. I could flip it around and say 5 plus 1 is greater than 3 minus